Okay, so we'll get started from where we left in the previous module. So as you can, if you remember, we were talking about how those pie charts are developed in towards the end of the previous module, and we looked at two different ways of doing it. One is the material flow, where what we essentially do is we try to come up with how much of a particular type of product is made, and then we estimate its shelf life, and then after say 3 years or 4 years the waste it will come into the waste stream, and that's the one way of doing it. The other way of doing it, what was I was trying to tell you towards the end of the last module, is this particular slide we were looking at, where we do a source specific approach. And here, as you can see, we were a group of us were trying to this is basically myself and some of my students, where we are trying to do a waste audit. This is also called waste audit, where we took we had the garbage, we took apart the garbage, and then as you can see over here, in this particular table, we put all those garbage after breaking those bags, and these are the black bags right there. And then if you can see, the pictures are not very clear, but there are lots of bins on this side, and then there are some bins on this side, as you can see. And so we are basically putting it into different bits, and so here again we are trying to sort through different garbage, putting it into different bins, and then we are bringing those bins here and the weighing them. So that's myself trying to do the weight, and so that's how we come up with different waste components. How much is paper, how much is plastic, how much is glass, and using this information you can prepare those pie charts, as we can see. So this was one, it was done several years back, and then I'll show you some a recent one where a group of students from my class, I think around 3 years back now, and they did a waste audit as well. And so this is a kind of lots of pictures. This is just to show you how it is done. This was not done on MSW stream. This was done just for the recycling stream. So we basically looked into the recyclable. These were the recyclable containers, trash cans, which takes only the recyclable material at the university setting. So here, as you can see, lots of plastics, lots of paper, cardboard. So those are the materials which is present over here. And these are the students actually from my solid waste class, which on that particular year. And this gentleman over here is our campus waste coordinator. So very excited, very enthusiastic person, and he was our campus. So this is, as you can see, the students are there. We have put a sheet of paper, we have a sheet of plastics, everything laid out, and it's a sheet of plastics laid out. We have several, like we are taking out the stuff, this cardboard boxes and other stuff we want to sort into these cardboard boxes for the different waste stream that is coming in. So unfortunate for us, on that particular day, one particular lab probably had a bad set of sampling bottles coming in. Maybe this was a discarded set of sampling bottles, so they discarded a lot of sampling bottles in that recycling container. So our data got a little bit skewed, so we got very high plastic. And at one point of time I was thinking that I will not use these slides for this lecture, but this is also one of the important, so you have to be really careful. So this was not a good day for doing that waste audit, because just because one particular lab had this huge load of plastic, as you can see in this particular picture, and this that led to a data which has a biasness. It's not really correct data, because this is not a typical sample. This is a very special kind of sample, you can say, where we had lots of plastics showing up in that particular day in this trash can, which was supposed to be for recyclables. So the students are taking these stuff away, and then they are weighing it. So lots and lots of plastic bottles, as you can see. So we weighed them. We sorted them in different categories, plastics, cardboards and other stuff, and these students are taking the notes. So this is basically, it's a good exercise, although it was not a perfect exercise, but it gives a very good idea to the students that how those pie charts are developed. So they go through the process, they understand the process. So that's what is the application. And in the engineering education, we need to bring in these kind of applications more and more in our classroom experience, or taking students out in the field and have these kind of things going on, so the students will appreciate the effort that goes into making these pie charts. So it's not an easy stuff, and you can see a scale. So we'll weigh things over here in those scales, and then the students are taking the different waste components apart, and then they are weighing them, and there are lots of pictures and then lots of plastics. So again, not a very good day. After weighing them, we are putting it back into the trash, to the recyclable can, because our goal was not to recycle it. Our goal is to actually find out the pie chart of the different waste components. So this is the students weighing them over there, and we come up that will lead to a pie chart like the one you saw it earlier. So this is again, it's a source specific approach where you can go ahead and do that. And we had another there was another time also actually so far if we get a chance later on, if we have time, we will show you some more examples of how this waste audit is done, which is a very important stuff. Because why this waste composition is important? Again, why this pie chart is important, because that pie chart will tell us what can we do with this garbage. Say if you want to design something, even if you are from a structural engineering class, if you have to design a beam for a building, first of all you need to know what is the load coming onto the beam. So then only you can go for designing that beam. Similarly here for the waste stream, we need to know what is there in the garbage. Then only we can decide whether to go for composting or anaerobic digestion or waste to energy, or nothing can be done and nothing has to go to an engineered landfill. So those things can be decided only after doing a proper waste audit. And when I say proper waste audit, in the Indian context, especially when you are looking at the municipal solid waste, the municipal solid waste that you and I produce at home and what ends up at the dump site as of today is very, very different. Now why it is different? If you think about the waste that you and I produce, we of course the paper and plastics and other stuff, for most of the middle class family and the semi-urban or urban areas, things are being taken up by these kabadiwalas. They will come and buy those newspapers and plastic stuff from us. So that doesn't go to the municipal solid waste stream, because that's already been taken away. And the rest of the stuff, even if there are some paper, there are some plastic which is actually mixed with the other, let's say we call it in a technical term, we call the contaminated waste. So even if it's recyclables are there, but it's already contaminated, it's with the food items, it's a nasty, cannot be recycled, the kabadiwalas will not buy it. So that will go to municipal solid waste. But even from the municipal solid waste, from the primary collection to when it goes to the secondary collection, we have the rack pickers and the people who will come there and try to take those stuff out as well. And then the food waste that we have lots of animals coming into those secondary collection point before things gets into the truck. We have the animals coming in, many times the cows or the deer, the cows, goats and other animals will come in and they will eat it. So if you do the waste sample and at the household level, and you do your design of a compost plant or anaerobic design plant, or you do a design for a say bioreactor landfill and estimate how much gas will be produced so that you can make electricity out of that, several megawatts, or even for your waste to energy plant. If you do all those by taking the samples from individual houses and not control the flow, so you are allowing rack pickers to come in and you are allowing this cow and other things to come in and to eat and everything. So you are not actually presenting a true picture, and unfortunately that is the scenario in most of the DPRs. Like I have been reviewing DPRs as part of the Swachh Bharat mission for several ULBs, and I do see the problem there. The waste sample that is collected from certain houses, it's not the waste sample that is ending up in the dump site today, because we don't have control in the middle. Our collection system is not, there are people coming into the collection system and taking out several stuff from the primary collection point, from the secondary collection point. So we need to actually do the sampling. We have to be really, I don't know the better, like it will depend from site to site. It will depend on what kind of collection system a particular ULB has, but we need to be really careful. So otherwise we will be having we'll set up a plant which will not work, and then unfortunately that technology which that plant is supposed to use, it gets the bad name. Technology is not bad. If a certain technology is being used in Germany, US or Canada or wherever, it is working with the garbage. The problem is we are not giving a proper input to that technology. And the problem is we did not did the homework properly. So unfortunately many times what happens is the technology gets a bad name, and then it becomes very difficult to bring back and use the same technology again, because once you like get a if somehow you get into the negative news, it's although it may be very good, but if it gets into the negative news, it takes a long time to recover. Recently we had the issue of Nestle Maggi, where the Maggi got the bad name and it took a while for it to recover. Maggi of course is a different ball game, so we cannot compare with the garbage technology, but just to give a perspective that anything which gets into a negative press, it gets very difficult to bring it back because people are afraid to try it out. So but we need to be really careful about, so waste composition is the bottom line. Before you start designing your ULB's integrated waste management plan, make sure you have really done well in terms of your waste composition pie chart, and this pie chart truly reflects the garbage that you are going to treat. And if you are not doing the job properly, I'm sorry, it's going to really it's not going to work. It will have a problem. It may work, but it's still there will be issues out of that, and there is a very good chance that there will be failure, and at that time it may be too late. So better to do the homework properly. So I think I have stressed upon that enough. So let's look at and we'll try to characterize the waste. The same pie chart, we'll try to characterize it in a different way. So here, if you want to characterize the waste for biodegradability, now what is the why we would like to do it? Again, every time I go there and first question I raise is why, because why we need to do this biodegradability. Biodegradability will do for, say, if you want to design a compost plant. Compost plant in Indian context, we have been trying to do compost. There have been some success story, there have been some failures as well, and there is a reason, especially for compost or anaerobic digestion, if we keep the organics separate from non-organics, or I would rather say from biodegradable fraction separate from non-biodegradable fraction, because plastic is also an organic, but if you can keep the biodegradable material separate, your compost will work and the anaerobic digestion system will work quite good. So what are those biodegradable components? Say if I want to, I'm sitting at IIT Kharagpur campus right now, and if I've been given a charge to find out for say Kharagpur town if we can have a compost plant. So first thing I need to know is, in terms of the garbage that is coming to the dump site today, and thinking that we are not going to change the collection system, or collection system will be like that, there will be rack pickers, there will be kabadiwalas, they will be there, because that informal sector is also part of the solid waste management system. They are not going to go away. If we think that they will, I don't know, but how they will go away, like we have to have a alternative. And why should they go away? Because they are doing a pretty good job in recycling anyway, especially the kabadiwalas. We need to do some skill development for them as part of the Skill India, or give them some technology so that they can do better, they can become entrepreneur, there could be Startup India and all those things coming in can be used for that. But they are doing a decent job. So I don't see any reason why this, especially the kabadiwala, is going away. The rack pickers are actually where they are getting a lot of human health problem and health issues associated with that. So we need to look at that part. But coming back to that original question that I'm raising, that if I have to design a compost plant for the town of Kharagpur, first of all I need to know that amount of garbage that will come to the compost plant, what is the biodegradable fraction? Do they have enough biodegradable fraction to make a good quality, to make a substantial compost, so that I can be able to sell those compost. The next thing is, is there a market to sell those compost? And if the market is not there, and say if I have to take this compost, if I'm making the compost at Kharagpur town and then I have to take this compost 100 kilometers, 200 kilometers to sell it, we should take into account the transportation cost. That is because that is also part of the cost, and the economics may not work because the fertilizer industry is there. We have the competition with them. Of course, the government is coming up with a subsidy where they are trying to force this fertilizer company to use part of the compost, and to make that we need to have a source separated organic fraction, because if it gets mixed with other fractions in there, the compost quality may not meet the compost standards. So those things we need to really think about. It's not that we want to make a compost, let's go ahead and set up a compost plant. Unfortunately, many times we do that, and that's not the way to, that it's better to do things properly rather than doing things like in a haste. There is a saying in Hindi that jaldi kijiye, jaldbazi mat kijiye. So like we have to do it things in a quicker way because we are already too late in terms of waste management system in the country, but at the same time we don't want to do it in hasty way. So we don't want to do it in a hasty way and after 5 years again we come up with the same problem that we have been doing for last say 40, 50 or whenever we have started working on solid waste management system, at least from 2000 onwards when we have the first waste management rules. So to set up before we go for the compost plant, we need to have to know what is the biodegradable fraction. And for this biodegradable components, what are those biodegradable components in a waste stream? So typically when we talk about the biodegradable component, we are looking at the paper, cardboard, food waste, yard waste. So these are the major ones. From an Indian context, most of the papers are if it's taken away by the rack picker, so it's not available. Cardboard could be also taken up, so it may not be available. So what we have essentially is the food waste and yard waste. Food waste, what happens? From our house, food waste starts traveling, but at the secondary collection point, part of it gets eaten up by cows, goats and other stuff. So you whatever food waste you think that you are getting, actually you are not getting that food waste when it comes to the compost plant, because things are getting eaten away. And if your collection system is not proper, if the waste is just sitting there for say 2 or 3 days, food waste will degrade. So part of the food waste has already degraded before it came to your compost plant. So we have to take those things into account. They may seem trivial, but they are not, because when you look at in totality, when you try to think, if you look at how much you are actually losing, that may result in your plant being from a making profit plan to a making loss plan, because there is always a lot of competition. So it's your profit margin is all not high, and we cannot run any system on subsidy for a long period of time. Government is providing some subsidy for compost right now, but how long government will be able to provide subsidy? And why should government provide subsidy to any business at all? Like at some point of time, the business has to stand on its own. So it's I don't at least in my view, we should have a plan for subsidy only for a certain period of time, just to help the industry set up, and then the industry should be able to run by itself. So the economics has to work for that particular. So again, for food waste, what you are getting at the site is not the amount that is getting from the house. Yard waste is whatever is that you have any like a wooden stuff, leaves and those kind of things, that's what the yard waste. And again, part of it could be eaten up by the cow, by the animals along the way as well. So those things has to be taken into consideration. And wood, leather and rubber, in theory they can degrade, but in practice they don't really degrade that much, because it takes a long period of time for them to degrade. So essentially we are looking at these four: paper, cardboard, food waste and yard waste. So yard waste is leaves and other stuff, that's what they're in a like a compost or from a biodegradable perspective. So to do that, we can explain, we can put this the same thing, same pie chart now in the form of what is known as the biodegradability characterization. Again, this pie chart is important. You need to have this kind of characterization before you start thinking about compost plant, anaerobic digestion plant, or even for landfill gas to energy kind of system, biomethanation system. So what we are looking at this pie chart, rather than putting into paper, plastic, moisture content and other stuff, we have put what is known as here, if you look at the terms here, we are calling it a biological volatile solids. One term we are calling it a biological volatile solids. We have other term which is known as the residual volatile solids. Then we have some inorganic material. Then the moisture is there. So let's look at each one of them. What is the biological volatile solids? Biological volatile solids is the organic fraction. It's the organic fraction of the biodegradable component which will get destroyed during treatment. So when we say destroyed during treatment, what do we mean by that? It's essentially that particular fraction. So this pie chart over here, this part of the pie is what it will actually react in the system. So when you put your waste stream in the compost pile, whether it's a agitated pile, there are different types of composting. We'll talk about that when we go to the compost chapter. But when we look at this compost pile, this is the fraction which will actually react. Rest of it will go into the system and will actually come out of the system. So you don't have, so this is the fraction which will react. So when we talk about how much oxygen needs to be supplied, is basically how much oxygen this particular fraction of the pie requires for the aerobic degradation in a compost pile. And then the green part at the bottom is what is known as the residual volatile solid. So this is also an organic, it's an organic fraction, but it does not degrade because see, it's a biological reaction. The biological reaction works based on the microbes, microbes are present, what types of microbes present. So microbes has a certain limitations as well, certain very high molecular weight compounds, very like a lot of bonds and a lot of like if it's a highly stable or certain compounds, those microbes cannot degrade. So although it's there, but it will not degrade. So that's the organic fraction of biodegradable component that remains after treatment. It will not really degrade. It's kind of similar to BOD and COD. Remember, if you had in your class, BOD is a biochemical oxygen demand, where you always, most of the time, most of the time your BOD numbers are much less than the COD numbers, because BOD is based on the microbial activity, COD is the chemical oxygen demand, very based on the chemistry. So you are using potassium dichromate and to basically oxidize everything which could be potentially oxidized. So similarly here, there are certain organic fraction which will not react by this microorganisms. So they will be there even after the treatment has been done. So that's our the biological volatile solids, very important. Residual volatile solids, together together these two, light blue and the green part, is what is known as the VS, volatile solids, which we talked about earlier. So that's why, remember, we talked about that volatile solids is an important parameter we need to know, but here it is, why we need to know. Moisture is needed for microbial activity, so moisture is present. Inorganic fraction, at least we need to know what is the fraction which will not react at all. So these are your glass, metals, dirt, inorganic part of the biodegradable material, so they will not react. So these are we need to have a pie chart like this. Say if you are in charge, or if you are working in a waste management area today, or if you whenever you will be working in waste management area, if you have been asked to say design a compost plant, design an anaerobic digester, or looking for gas from the landfill, you should have a pie chart like this in front of you before you start designing your system. And you need to develop this kind of pie charts by doing the sampling and other stuff, because that will be a correct approach of doing it, rather than so to do things in a more perfect way, so that you can do things correctly. So that's the conceptual ways for the biodegradable characterization, and we'll look at the other characterization as well. So how you determine VVS, how we do it. We can run a test in the lab and measure it. We can run a test and see how much got degraded, and then we can do that. We can analyze a surrogate parameter. Surrogate is a term where it's essentially, rather than using that biological fraction directly, we are actually doing it by measuring something else, and that something else is called, it's what we most of the time we use is lignin content. What is lignin content? Lignin is a compound which you may have heard about. Lignin is very hard to degrade. So if we know that, although it's organic, but it doesn't degrade, it will be like part of your RVS. So and it does degrade theoretically, but it takes long time to degrade. So higher the lignin content, as it's hard to degrade means what? Higher the lignin content, lower the biological volatile solids, isn't it? And I think we'll see it in the next slide or so. So we use lignin content as a surrogate parameter because we can analyze for lignin in using analytical instruments, and that's used as a surrogate parameter, and then we can calculate this BVS upon Vs, which is also known as the biodegradable fraction. This BF is known as the biodegradable fraction, and BVS is the biological volatile solids, Vs is the volatile solids. So this can be estimated by this particular formula, and it's a empirical formula. It had been developed based on research done earlier. So here it's 0.83 minus 0.028 times LC. Now what is LC? LC is the lignin content expressed in percentage. So you need to be careful. So you need to remember that it's always lignin content in percentage. So 0.83 minus 0.028 times the lignin content, which the lignin content is expressed as percent. So as you can see from this formula, as you have more and more lignin, that means less and less biodegradable fraction. Because it's a negative term here. So it's more the lignin, higher it cannot be degraded. So that gives you an idea about. So using lignin content, we can find out the biodegradable fraction. Then other way of doing it is you can do a BMP test, what is known as the biochemical methane potential test. What is the biochemical methane potential? Biochemical methane potential is as you take the sample, you bring the sample to the lab, you do some sampling of the solid waste and bring it to the lab, separate into different fractions and process it, then you put it in what we known as the BMP bottles, and then you have the reaction going on, you put some bacteria in there, the bacteria will start degrading it, and we do it in an anaerobic system. In an anaerobic system, we'll have methane being produced. So this methane will measure how much methane is produced, and based on the methane production, we can estimate what is the biodegradable fraction. So I'll walk you through how it is done, and that will make you a little bit clear. So in next 3-4 slides, we'll explain that and to how this BMP test is done. So this is here, if you look at this particular slide, this kind of gives us the big picture overview. So we collect the garbage, so you collect the sample, and this is how the sample is collected. So here you can see from, and we'll come back to that slide in a minute. So here this is from an existing landfill. So we were actually drilling the landfill. So as you can see, we are doing some drilling over landfill and then collecting the samples from these places. That's myself trying to collecting samples from a waste landfill site, and here what we were trying to do is we were actually trying to find out how much of the biodegradable material left at this landfill, and if we can set up a gas collection system, whether there will be enough gas produced so that in the next door they were trying to build a asphalt plant, so that whether we can supply energy from this landfill to the asphalt plant. That's what the reason for this analysis. But so this is how you collect the sample. This is one way of collecting sample if you're doing it at an existing landfill. If you have a raw sample, like we want to have a municipal solid waste just collected from a landfill site or from the individual household, primary collection or secondary collection, we can use that as well. So once the waste is collected, you bring it to the lab. And then here the waste is collected, you bring it to the lab, and what you do it after bringing to the lab, here your waste is collection is done, you bring it to the lab, then you separate the garbage, as you can do a garbage separation. And how we separate is how we take a biodegradable fraction. Now how we take the biodegradable fraction, we look at it. We look at it, paper, those 3-4 paper, cardboard, food waste, yard waste, we separate them and we put it and I will show you in the slide right now, and that becomes our biodegradable fraction. We grind it, we measure the total solid, we measure volatile solid, we do the BMP assay, we analyze the gas over 45 days period. Anything which is, then we also do the sieve analysis. Anything which is retained on number 40 screen and which also passes through 40 screen, we take both, grind them as well, we do the total solid and BMP assay on them. Why we do this? Because these fractions there may be certain organic material present in these fractions which cannot be captured directly here in the biodegradable fraction because of particle has already gone into small pieces. These two are more common when we are actually trying to take the garbage coming out of the landfill. If it's a fresh garbage, most of it will be on this side. But many times we are actually doing this BMP test on semi-decomposed garbage as well, where we have to do all those 3 parameters. So once how these are done, you saw the picture of how the waste is collected. The after waste collection, this is the waste, how the sample is processed. So we'll dry the sample here, so we'll put it in an oven. It's put it in an oven and we are drying the sample. After drying the sample, we shake it. This is the number 40 screen. Whatever is passing through 40 and whatever is retained on 40, we take both, and then we grind all these samples over there. I'll show you. This is the waste manually separated. So this is your yard waste, paper. This is a biodegradable fraction. Plastics, metals, we don't take them into account. So only biodegradable fraction for the first part. Then you grind it using a grinder, and then you have the ground up sample. This is a example of the ground up sample. Then you put it in a BMP bottle. So this is your samples over there. As you can see, this is the sample over there, and this sample, as you can, and here we have this white powder that you see is the glucose. So that's used as a positive control. So we have sample. We'll add some inoculum. We'll add some bacteria to it, and let it get the reaction going on over a period of time. And so this is the with the inoculum, as you can see over here with the inoculum. So serum bottle, we incubate at 35 degrees centigrade. So as the gas is produced, we analyze this gas using GCTCD. So that's we use the GCTCD to analyze the gas, and then the gas, we take the sample from here, inject into here, and then we analyze the gas. And that process is done over a 45-day period, typically 45-day period. Why 45 days? You will see in that graph when we show you. It's after 45 days, things starts flattening out. So if you see this picture, started actually getting straight. So no more, and this is a cumulative. This is a cumulative graph. As you can see, cumulative methane volume. So what it shows that after 40-45 days, there is no more further gas production. Whatever gas could be produced is already produced. So then we can stop, and then we can find out how much gas was produced per unit of that particular material, and that way we can know what is the biodegradable fraction of that. So this is, but it's a time consuming process, of course. It takes time, it takes money, and many times it's needed. It's actually, it will save you money later on. So many times what we try to do is to have, to save our project cost, we try to avoid doing this test at the beginning, but later on we ended up designing a system which doesn't work. So we need to we need to be rather do it properly from the beginning. Here are some examples of the different biodegradable fraction, which is paper and cardboard. As you can see, you will see the food waste. If we have the food waste here, here the percentage of MSW, biodegradable fractions of MSW around 10.1%. Paper and paperboard is actually the this is the actually percentage of MSW in a typical MSW. This is how much they are. And again, this data is as most of these books are written in Western countries. This is a typical waste composition from a Western country. If you think about India, we will have more food waste. Will not have this much paper and cardboard because our Kawadiwala does a very decent job in India. So you will not see this much paper and these things coming up. But this is a typical MSW from say US MSW, and this is an important thing for present discussion is how much of percent here actually. So nearly 50% of the paper and cardboard is biodegradable, 82% of food waste is biodegradable, 72% of the yard trimmings are biodegradable. So even not 100% of the food waste, around 17-18% of the food waste is not biodegradable. So that's also, so this is just to illustrate those points. So let's, so that's kind of gives you that example, and let's kind of stop over here, then we'll try to look at from a thermal characterization of the waste. So what we have tried to cover in this particular module is in terms of the waste component system, integrated waste management system, and then we looked at the biodegradability kind of characterization. Next we'll kind of continue this and we'll look at the thermal characterization and then some other analysis part of that as well, how things are analyzed, some of the statistics involved with that, some more examples will be done. So I hope you're enjoying this course, and this, I think this video completes the second week of the material. Again, you will have the quiz every week. We'll have a quiz, but the discussion boards are there. I will look forward to receiving your suggestions, questions. If you have any suggestions on the course material, you are more than welcome to do that as well. And I hope we'll make it more enjoyable and over the coming weeks. Okay, thank you and enjoy the course.